This is the example problem for complete problems 1, specific heat, in Unit 2. This problem says an 84-gram piece of metal is in boiling water and has an initial temperature of 100 degrees Celsius. The metal is removed from the water and cools to 16.3 degrees Celsius. 9540 joules of energy are released. It asks, what is the specific heat of the metal? Well, let's see what we know in the problem. We have this value right here. That's going to be 84 grams. Grams tells us its mass. We have 100 degrees Celsius, a temperature reading. 16.3 degrees Celsius, another temperature. And 9,540 joules, which is an energy measurement. Because we have a substance whose temperature is changing, we have the mass, the energy, and we're looking for the specific heat. The specific heat equation, Q equals mc delta T, is a good equation to use. We have Q, M, we're looking for C, but we don't have delta T yet. We know initial temperature and final temperature, so let's use this equation to find delta T. We'll plug in final temperature, 16.3 minus initial, which is 100. That actually gives us a negative number. Delta T equals negative 83.7. I'm going to show you how the math works out just fine so you don't end up with a negative specific heat. This amount of energy is released, so it's going to be a negative amount of energy. So I plug in negative 9,540 joules, because remember, for energy, if it's being released, the block is losing that energy, so its energy change is negative here, equals mass, which is 84 grams, times C, which we don't know yet, that's specific heat, times delta T. First step is to multiply 84 times negative 83.7. We get negative 9,540 equals C times negative 7,030.8. To get C by itself, divide both sides by this number right here. Punch that in your calculator, and you'll see that the specific heat is 1.36 joules per gram degree Celsius. And then you can plug that up here, and you're all done.